A couple of sets of data to determine um, which one, if not both, may have the characteristics of an exponential function. And just kind of backing up for a while, we looked at arithmetic sequences, and with arithmetic sequences, we had what was called a common difference. And if a set of data has an exponential behavior, then we're going to see that it's got a common factor or a common ratio. So let's see here what we have. We start over here over on the left, and I'm going to go, even though really our focus is on the change in y, we are going to look at the change in x to see if it is whether we have regular intervals. And let's see, so 0 to 3, we got a change of 3, 3 to 6, 3, 6 to 9, 3, 9 to 12, 3, 12 to 15, 3. So we have a change in x of 3. And then for our change in y, let's see, 12 to 16, is 4. And 16 to 20 is 4. And 20 to 24 is 4. And 24 to 28 is 4. And 28 to 32 is also 4. And we would say that we have a common difference in our values of y of 4. And that would be characteristic of an arithmetic sequence, which gives us the behavior of a linear function. And in fact, our change in y over the change in x is actually 4 over 3. Now let's look at this second set of data. And again, we're going to look at our change in x. Well, 2 to 4 is 2. 4 to 6 is 2. 6 to 8 is 2. 8 to 10 is 2. 10 to 12 is 2. So we got regular intervals of x. But what about our change in y? Well, let's first look to see if we got any kind of common difference. Well, 1 to 4 is 3, but 4 to 16 is 12. And 16 to 64 is, wow, what is that? 48. And the difference between 64 and 256 is 290. Is that right? 192? Yeah, 192. And the difference between 256 and 124, let's see, 4 minus 6 is 8. Take away the 1. 11 from 5 is 6. And then we've got 9,768. Well, obviously we don't have a common difference. So let's see if we got a common factor. Let's take our change, our second change, 12, and divide it by 3. Well, let's see, 12 divided by 3, that equals 4. And then let's go 48 to 12. 48 and 12, well, that equals 4. And 192 divided by 48, let's see, maybe easier to think about 48 times 4. 4 times 8 is 32. 4 times 4 is 16 plus 3, 192, yeah. And how about from 192 to 768? Let's take 192 and multiply it by 4. Let's see, 4 times 2 is 8. 4 times 9 is 636, carry 3. 4 times 1 is 4, plus the 3, 768. Yeah, so we have a common factor of 4. And just for fun, what about so we got 4 times. Well, this gives the characteristic of an exponential function, the fact that we've got a common factor. So if it's an arithmetic, if our series of data is arithmetic, it has a common difference. If it is geometric or exponential, it has a common factor. So this one on the left, no, it does not give us exponential behavior, but the one on the right, yes, it does, because we can see a common factor.